Welcome to the Explainer. Today, we're going to dive into a really cool concept that powers a ton of the AI you probably use every single day. So here's a thought. What if AI didn't have to learn from scratch every single time? What if it could take a shortcut?
Okay, so to really get why this shortcut is such a big deal, we first have to appreciate the problem it's solving. So let's just ask the big question. What does it actually take to train a major AI model from the ground up?
Well, the answer is a mountain of resources. And I'm not kidding. We're talking about absolutely massive amounts of data, like unfathomably large. Then you need huge computational power. We're talking supercomputers running for weeks, maybe even months. And all of that costs a ton of time and money. It's a truly massive undertaking. So what's the big deal? Well, this incredible cost creates a massive barrier to entry. I mean, think about it. If every single AI had to be built this way from zero, innovation would basically be stuck with only a handful of giant companies that could afford it. But that problem, right there, leads to a really powerful, kind of game-changing idea. What if AI could do what we humans do all the time? What if it could, build on what's already known? Instead of having to relearn how the entire world works from scratch every single time? And that brings us to this really elegant solution. It's a technique called transfer learning. And honestly, it's one of the most important concepts in modern AI today. So what is it? At its core, the idea is actually pretty simple. You take a model that's already been trained on a massive general dataset. Think millions of images from all over the internet. And then you take all that knowledge it's learned and you transfer it to a new, much more specific problem. Here's a good way to think about it. Imagine a model first reads an entire encyclopedia, right? It learns all the basics, what edges look like, different textures, common shapes, what a tree is, what a car is. Then, when you come along and ask it to do a specific job, like just identifying cats and dogs, it doesn't have to start from square one. It doesn't need to learn what fur or an ear is all over again. It just applies all that foundational knowledge it already has. And the benefits of this approach, they're huge. I mean, it makes building powerful AI way cheaper, much faster, and honestly, a lot more accessible to everybody. Because, you don't need a supercomputer in your garage for every single new project. Okay, so how does this transfer of knowledge actually happen? Well, in practice, there are a couple of key ways people reuse these pre-trained models. All right, so there are two main approaches here. On one hand, you've got feature extraction. Think of this like taking the pre-trained model and just freezing it. You use it as is, and you just tack on a new, small decision-making part at the end. The original brain is locked. On the other hand, you have fine-tuning. This is where you unfreeze some of the top layers of that original model. This lets its brain adapt just a little bit, kind of tweaking its existing knowledge to better fit the new job. Okay, theory is great and all, but how well does this shortcut actually work in the real world? Let's look at a little showdown, a practical test using a famous image dataset called CIFAR-10. So the challenge is pretty straightforward. We've got one model that's trying to learn to classify these teeny tiny 32 by 32 pixel images completely from scratch. And in the other corner, we have a model that's using transfer learning. Specifically, it's a powerhouse model called Inception v3, which was already pre-trained on the gigantic ImageNet dataset. And the results? Wow, they are dramatic, especially right out of the gate. I mean, look at this. After just a few rounds of training, what we call epochs, the model starting from scratch is still kind of stumbling around, right? But the transfer learning model? It's already performing way, way better. It gets this incredible head start. And this is exactly what the research shows. These pre-trained models get up to speed so much faster because they're leveraging all that foundational knowledge they already have. This speed up, this acceleration, is seriously one of the biggest wins you get from transfer learning. But, and there's always a but, right? It's not a magic bullet. This shortcut has its own limitations, and honestly, understanding when it doesn't work is just as important as knowing when it does. And this brings us to a really crucial question. The experiment showed that while the transfer learning model had this huge lead at the start, the model trained from scratch did eventually start to catch up. So why? Why didn't that massive initial advantage just lead to a complete blowout victory? Well, the answer really boils down to the data. It's all about context. See, the knowledge that the big Inception v3 model had was all based on big, high-resolution, really detailed photos. But the new task, It involved these tiny, blurry, low-resolution images. And that mismatch, what we call a domain difference, really limited just how useful all that prior knowledge could be. So this really highlights a couple of key things. First, how similar your old data and your new data are is absolutely critical. It's not just plug and play. And second, with fine-tuning, you have to be careful. If you're not, the model might just end up memorizing the new data instead of actually learning from it. That's a classic problem called overfitting. So at the end of the day, what's the takeaway? Transfer learning is an incredible accelerator. It gives you a stable foundation, a massive head start, but it's still a tool. And just like any powerful tool, it needs a skilled user who really understands the specific problem they're trying to solve and the data they're working with. And this really leaves us with a final thought to chew on. By letting AI effectively stand on the shoulders of giants, transfer learning is speeding up a future where development is faster and probably way more creative. Which leaves us with the big question: what will it build next?